This is a small demo on how you can use version control systems with locally available CAD files. Softwares like Onshape, which are cloud-based, offer version control straight out of the box. But for users who use SolidWorks or CATIA, which deal with locally available CAD files, they're left at a disadvantage. So this video aims to alleviate their problem. We'll get into the benefits of version control as we progress throughout the video. So let's hop straight in. Firstly, so I'm using WSL, and you can Google all of the commands that I'm about to use. They're pretty straightforward. And we are inside our working directory. So if we do an ls, it's going to list all the files, and initially it's empty. So let's go ahead and create our first part. Let's define the necessary relations. I'm creating an L-shaped small bracket. Okay, that should do it. So you can define it more, add more smart dimensions and whatever. But for the sake of this example, we are gonna just extrude it. Let's do mid plane, 50. Perfect. So this is going to be our small extrude, or the bracket that we are going to deal with. And so let's save it. And it's going to save it as a .sldprt, which is the standard file format for SolidWorks. Let's save it. Okay, so now if we hop into the terminal and do an ls, you're actually going to see two files. One, the bracket.sldprt, and the second one, the $bracket.sldprt. As long as a part is open, SolidWorks is going to create the dollar file, which is a log file. So if you close the part and hop back into the terminal, we only have the .sldprt. Now this is an important caveat, and we are going to see the reason for why. So now that we have created our first part, let's start with version control. So you can see any tutorial on how to install Git CLI, but most of these things come pre-installed with it. So we can tell Git to start tracking our repository. Now a repository is just a small fancy name for a folder. So we can tell Git to start tracking our folder with the git init command. This is going to tell Git to start tracking this, and okay. So now that we've created this, let's do, and we have our part. The next thing we want to do is to add Git LFS. Now, LFS stands for large file storage. Whenever you are dealing with large binary files in Git, you tend to keep them in LFS. Now, LFS is essentially a small extension sort of Git, which keeps the large binary files in a separate Git LFS server. So, and keeps a reference pointer from the main report to that. So this means clones, commits, push and pulls are much faster. So let's install Git LFS. You need to do this once per folder. You can do that with Git LFS install, and LFS has been initialized. So now we want to tell LFS that we want it to track all the .sldprt files. You can do that with so the star.sldprt tells that irrespective of the file name, we want Git to track all .sldprt files. So hit enter, and while we are at it, we can also do sldasm, since you'll be using assemblies as well. And we can also do sldbrw for SolidWorks drawings. Now, if we do Okay, we can do, so it would have created a Git attributes file, which we can access with Nano. Now, Nano is just a simple terminal text editor. You can use Notepad or any VS Code code editor to view this file. And here, these three lines tell Git LFS that it has to track the files with these extensions. So let's not touch this and exit. And that's how you configure Git LFS. The next thing to do is to add a Git ignore file. Not right now, but later down the lane when you will be running animations or simulations, there'll be a lot of .mp4 files or other simulation files which you don't really want to push to JIT. So we want to tell JIT not to track all those files, and that can be done through the .jit ignore file. So we create it with the touch command, which is, this is going to create the .jit ignore file, and we can hop into that file with Nano. Here we want to tell JIT expressly not to track few files. So let's start with star, which is going to tell JIT not to track any files at all. It's counterintuitive, but you'll see why. Then we want to tell to track any folders or subfolders. So if you have a few parts located in, say, folder 1/part, it's going to tell JIT to track that. The exclamation tells it to track that here. And then we say, so this is for the nested parts. If you have it in any folder, the first line tells you to track all the subfolders as well. And while we are at it, we also want to add the files for assemblies and the files for drawings. And we also want to tell it to, of course, track itself. And we want to tell it to track JIT attributes. So let's exit. Perfect. So the next thing to do is to actually track all the files. So this can be done. So first make sure that the log files aren't there, which is not. So we can start tracking files with the git add command. The dot command tracks all files, adds all the files to git tracking, and if we hit enter, it's going to start tracking them. And the next thing to do is to make a commit. Commit can be made with the first commit. So if we do that, it has created three files, the JIT attributes, JIT ignore, and the bracket.sldprp. So this completes phase 1 of the video, and we'll see what to do next. Is that you absolutely never want to add to tracking or make a commit when SolidWorks has generated the log files. They can be a real pain to remove and often end up confusing the user as he doesn't know which one to use. So always be careful never to make a commit whenever SolidWorks has opened or generated the log files. Now that we've made our first commit, let's move on to understanding the benefits of using version control. Before we move on, there's one other thing that I've forgotten to show, which is doing a git LFS ls files shows all the files that are under version control with git LFS. So right now we just have the bracket, and doing enter should give just the bracket. Okay, so the important feature, one of the most important features of git is branching. So the master you see here is the master branch that we are currently in. It can be named as main or whatever, but for now let's keep it master. So consider this. This is our bracket. And after we've come till here, my teammate wants to add a rib in the middle for structural support or whatever. But I'm not really sure if I want to add it onto my part. The conventional way to do it would be to copy the part to some other place and make the change on the second part. But with JIT version control, it becomes a whole lot easier. Let's see how. So let's close this and hop back into the terminal. So we can check out a new branch, and that's where you can do JIT checkout -b, let's call it rib. So this switches us to the branch called rib. Now let's hop back into SolidWorks and create our rib. So let's create the rib with the rib command. For some reason, these automatic dimensions aren't working in my PC. Okay, so this is defined. Let's do rib and we'll leave it to the defaults. Okay, so now we have a rib and let's save it and let's close it. Coming back into the terminal, if we do a JIT status, we can see that we've modified the bracket.sldprp. So to the next step, we need to make a commit, which is JIT add dot. You don't really need to do it, but it's just habit for me. Then we need to make the commit with JIT commit. Let's call it add rib feature. Hit enter. And we can see that one file has been changed. So let's, okay, coming in SolidWorks, we can see that this bracket has the rib feature as so. Let's close it. And let's now go back to the master and see what is there. Another important caveat here is to always close your files before switching branches. It can without closing the file, if you switch branches, it can inadvertently overwrite the files, which can be a very nasty mess to clean up later. So always be careful to close the file and only then switch branch. So let's again go back to JIT checkout master. And now if we open the part, we have no rib. So my original part, which is the bracket, stays like this in the master, while the one with the rib is having a different feature in the branch of rib. So this is a really handy in version control. You can merge the rib branch back into master, and we'll see how to do that in a while. So we can actually take this a step further and create a branch from a branch. Let's see how. Let's close this, come back into master. So let's go back to rib. Okay. Now, as you can understand, probably we are on master, from which we've taken a branch called rib and we've created the rib. We can actually take another branch, let's say we'll call it fillet, where we can implement another feature on the rib, but the master will be different from both of them. So let's do that. We can do JIT checkout. Let's call it you need to include the -b flag only when you are creating a new branch. Otherwise, it can be just JIT checkout branch name. So we are creating a new one. So it will be, let's call it JIT checkout fillet. So let's go there, and we have switched to the fillet branch. So now let's open the bracket. Okay, so say we want to add a fillet over here. Let's decrease the radius, maybe not that much. Here and here. Let's do it here also. Oops. Okay, these 4 edges. So now we've added the fillet. Let's save it again. Close the part. Come back into terminal. And now if we do a JIT status, we've modified the bracket.sldprp. we can add it with, okay, let's not add it. We can directly do git commit add fillet feature. Again, one file is changed. So we are in fillet and using, if we see the bracket, we have with the fillet. So let's close it, head back to git checkout rib. And here, if we open the part again, we have it without the fillet. Let's close it, head back again to master. And if we open it again, we have it without the rib as well. Now, I understand opening and closing the file so many times can be a real pain, but having multiple copies of it and juggling which one is the correct one is much more difficult compared to this. And all the files we've seen are under version control. So for some inadvertent reason, even if one of the files gets corrupted, you already have a local backup of it. So let's actually, now that we have the fillet feature, let's actually merge it back into master because we liked how the fillet has come out. We can do that with git merge. We are already in master, so you need to be in the branch to which you are merging. So we want to do git merge and we want to give the name of the branch. You can also do git merge rib, but fillet contains both the features rib and the fillet, so we are going to directly merge fillet. Let's hit enter. Okay, so one file has been changed. Now we are in master, and if we come back and open the part, boom, there you have it with the rib and the fillet. Now I've taken pretty simple things like just a rib and a fillet for the sake of this example, but I hope you can understand how handy and how powerful this tool can get as the features and as the parts you build get more and more complex. Of course, you need to remember to close the part every time, but it's a really, really handy tool. So let's come back here. And now we have seen how to manage branches and what we can do. Now that we've merged through the master, let's move to another powerful feature of Git, which is hosting things in the cloud. Another important or very handy command is the git log one line. So the one line flag keeps it concise while just git log gives a detailed commit history. Doing this shows all the commits that are in master. So we have the first commit and rib feature and fillet which have been merged from the fillet branch. So let's exit. Okay. Now, to push things to a remote repository, you actually need to create a repository first. So let's head over to Git. And here, now this is github.com and I've signed in with my credentials. Let's say bracket. Let's name our repository as bracket and it will be anything you want. And let's actually create the repository. Okay, so now we have an existing repository. So let's copy this as is. So if you notice, all these things are with git at github.com. So they require you to set up SSH in your terminal. SSH stands for secure shell. And there are plenty of tutorials out there on how to do it. So I'm not going to get into it. So we've copied this. Let's head back and do git. Okay, let's actually paste it. Git remote add origin git at github.com. Okay, let's hit enter. And keep in mind that we've committed everything. Otherwise, it can be, you need to commit all the changes you've made. Only then it gets sent to the remote repository. Okay, so we've added where the remote repository is. Now, so git branch -m. This is just to rename the master branch as main, but I'm not going to do that since I'm old school and I prefer to stick with master. And then git push this one. So let's do git push -u origin master. Let's keep it master only. The -u flag sets the remote as upstream. So from next time, you can just do git push or git pull, and that's gonna work. So let's hit enter. And since all changes have been committed, so give it a minute. Perfect. So now let's head back here, and if we refresh the page, we have the bracket.sldprp. Perfect. Now, another quick fact or feature that many people don't know about JIT is that it offers a 3D viewer in the browser to view parts. So JIT actually supports, when people upload CAD files. But the thing is, it only supports .step files, and so even the bracket.sldprp can't be viewed in the JIT browser. But if you are working with step files as such, you can just open it, you can just click on it, and it will show a live preview in a 3D environment in the browser. Okay, let's head back here. And yeah, that's pretty much the main features of how and why to use JIT. And there are two other features which are pull requests and JIT rebase. These two features are very powerful once you know how to use them, especially when you're working with teams. So I leave you to it to check out how to use them. There's one other thing that we wanted to check out, which is you can not only push the master branch, but push other branches as well. So say you haven't merged the rib or the fillet branch onto the master, and you want to actually create two branches for your other teammates to check out which is better. You can do that with JIT. First, you have to check out to the other branch. Say we are pushing the rib. So let's check out to the rib. And now we can do JIT push. You don't need to add the origin again. And this time it's going to be rib. And if we push it, again, give it a minute. Okay, let's come back. And if we refresh it, we have two branches here, master, which is the default one, and rib. So if we go there, we have the add rib feature commit. So this bracket, we can be sure that this bracket is just a simple bracket with the rib. And in the master, this bracket has a rib and a fillet. Perfect. Another helpful feature is to use JIT pull. Okay, so we've set the -u as upstream. So from now on, whenever you want to push any other changes, you can just do JIT push. Not only in rib, but in any branch, you first need to set the -u as upstream, and then you can just use JIT push. Alternatively, you can use JIT pull as well to pull changes from the remote repository onto your local machine. Of course, now we don't have any further changes, so it's just going to say it's the same thing. But if you do have any changes, say like a teammate has pushed further changes to the remote repository and you need to quickly get up to that, you can use JIT pull to bring those changes onto your local machine and view them in SolidWorks. Perfect, right? So this is the pull request that I was talking about, which is a very powerful feature that you need to check out. So do check it out. That's it for this video, and I hope you learned something new, and until next time.